Hi all. So today we will see the application of matrices. So these are very important tools for engineering fields. So first we shall go through the fields where matrices are used. The use of matrix is very important and has become very common in the past few decades in almost every field. Some of the subjects, the field in which they are used physics related applications of circuits. Number 2, cryptographic. Number 3, data representations and recoding. Number 4, in economics. Number 5, in maths and calculations. Then last one is robotic. So what is cryptographic? So cryptographic is concerned with keeping communications private. It consists of mostly encryptions and decryptions and aims at keeping data hid from whomsoever it is not intended for. So this is cryptographic. So cryptography is very important one for every electronics systems applications, even during the mobile phone also. So in WhatsApp means we have encryptions and decryptions are present here. So cryptography is very important tools based on the matrices. Matrices are their inverse used in the programming for their coding or encryptions. The message is made as a sequence of numbers in a binary format for communications, and it follows code theory for solving. One type of code which is extremely difficult to break makes us of large matrix, that is encoding matrix. To encode a message, the receiver of this message decodes it using the inverse of the matrix, that is decoding matrix. So encoding decoding means encoding is sending the message, decoding is the receiving message, that is we can take the inverse operators. Then in economics, matrices are used to calculating the gross domestic products in economics, which eventually helps in calculating the goods productions efficiently. For computers and graphics, the computer based applications, matrix plays a vital role in the projections of three dimensions image into two dimensions screen, creating the realistic seeming motions. This is a graphic field. The non-graphic fields focus many departments, one of them being Google searches. Stochastic matrix and eigenvectors solves are used to page rank algorithm, which are used in the ranking of web page in Google searches. In physics related applications, so the matrices are applied in study of electrical circuits, quantum mechanics and optics. In a calculation of battery powered outputs, registers conversions of electrical energy into another form of energy. This matrix plays a major role in calculations, especially in Kirchhoff laws of voltage and currents. So here is Kirchhoff law is very important things. So first we can see the one application problems. So this is a very important problem. Obtain the principal axis and principal stresses for the three-dimensional stresses distributions given by the stress tensors A equal to tau xx, tau xy, tau xz, tau yx, tau yy, tau yz, tau zx, tau zy, tau zz. So this can be written as a matrix form 3 1 1 1 0 2 1 2 0. So everything is given in the problem. So here is we have to obtain the principal axis and principal stress for given three-dimensional distributions. So first we can see one by one here. So first we can go through the normal stresses are tau xx, tau yy and tau zz. This is a normal stress where tau xy, tau xz, tau yx, tau yz, tau zx and tau zy, the shear stresses are acting on the body. The principal axis of the stress tensor capital A corresponding to the orientation of the axis for which only normal stress act on the body. That is, there are no shear stresses. The principal axis of eigenvectors of the stress tensor capital A. The eigenvalues of stress tensor are the magnitude of the principal stresses, that is a normal. Therefore, to find the eigenvalues and eigenvectors of capital A, that is, we write determinant of A minus lambda I into x equal to 0. So main concept is we have to find the principal axis and principal stresses based on the eigenvalues and eigenvectors. These are continuations. So first we can take the given matrix capital A equal to 3 1 1 1 0 2 1 2 0. First, to find the characteristic equations. What is the characteristic equation formula? Determinant of A minus lambda I equal to 0. So therefore these are 3 cross 3 matrix. Therefore the characteristic equations is lambda cube minus d1 lambda square, then plus d2 lambda minus d3 equal to 0. So first we can find one by one here. So first we can find the d1. What is d1? d1 is nothing but the sum of the diagonal element. So 3 plus 0 plus 0. So answer is 3. Then d2 is minor of the diagonal element. That is d2 equal to, first I can take the minor of the diagonal element. First I can fix 3. So we can omit the first column and first row. The remaining matrix is 0 2 2 0. So I can write here. Then plus. Next I can take 0, that is a minor of the matrix. So I can omit the middle column and the middle row. So remaining element is 3 1 1 0. Next plus. Next I can take the last minor element, minor diagonal element. So you can omit the last column and last row. So 3 1 1 0. So equal to, just like a matrix multiplication, 0 into 0 into 0 is 0, then minus 4. So we get minus 4. Then plus 3 into 0, then 0, 1 into 1 is, we get minus 1, so minus 1. Then 3 into 0 is 0, then 1 into 1 is minus 1. So next we can adding this 3. So minus 4 minus 1 is minus 6. Then d3 is determinant of A. Everyone is familiar to find the determinant of A. So first we can take 3 into this value, then your formula minus 1 into, so we omit the middle column, then upper row. So we get 1 into 0 0, then 2 into 1 is minus 2, we get the value. Then last one 1 into the remaining elements. So our answer must be minus 8. So everyone is familiar to find the determinant of A. So here is, I am not elaborate here. So d1 d2 and d3, and substitute the value d1 d2 d3 in the characteristic equations. Therefore we get lambda cube minus 3 lambda square minus 6 lambda plus 8 equal to 0. So these are characteristic equations. So next to find the characteristic roots. So therefore here is, I can explain the synthetic divisions. So your equation is lambda cube minus 3 lambda square minus 6 lambda plus 8 equal to 0. So equating the coefficient, first highest coefficient is lambda cube, that is 1, then minus 3 minus 6, then 8. Then using a synthetic division, first element is, we can put, first element is always put 0. So we can 1 plus 0 is 1. So first we can take lambda equal to, choosing the value, your remainder must be in 0. For this case we can put 1 by 1. First I can put lambda equal to 1. Suppose your answer is not equal to 0 means, next we can take lambda equal to minus 1. That is also not equal to 0 means, so next we can take lambda equal to 2, then lambda equal to minus 2, like that. The idea is we can reduce the third degree in terms of second degree. So here is, I can choose lambda equal to 1. So first I can take, put here is 0 is always, so 1 plus 0 is 1. So 1 into 1 is 1. Then 1 minus 3 is minus 2. Then 1 into minus 2 is minus 2. Then minus 6 minus 2 is minus 8. Then 1 into minus 8 is minus 8. Then adding this 2 means we get 0. So therefore lambda equal to 1 is satisfied. So next rewrite the given equations. These are higher order. So lambda square minus 2 lambda minus 8 equal to 0 here. So next we can factorize this one. So how can factorize here? So here is, I want minus 8. So we can split minus 2 here. So we get 4 into, that is 2 into minus 4. So we get minus 8. What is 2 into minus 4? So 2 minus 4 is, we get minus 2. Therefore lambda minus 4 into lambda plus 2 equal to 0. That implies lambda minus 4 equal to 0 and lambda plus 2 equal to 0. So that implies lambda equal to 4, lambda equal to minus 2. Therefore the rules are lambda equal to 1, minus 2, 4. So that is here is 1, 4, minus 2. Okay, so these are eigenvalues. So next to find eigenvector by using eigenvalues. So the characteristic equations are a minus lambda I of x equal to 0. So a minus lambda is nothing but, so we can separate the minus lambda from the original given matrix, that is diagonal element 3 minus lambda, 0 minus lambda, 0 minus lambda. This is the idea. So a minus lambda is nothing but we can subtract minus lambda into the diagonal element from the given matrix. So therefore, so 3 minus lambda, what is 0 minus lambda? Minus lambda, again 0 minus lambda is minus lambda. So this is a minus lambda a. What is x here? X is a 3 cross 3 matrix. So here is I can take x, y, z, or we can take a, b, c, or you can take x1, y1, z1. So that is your convenient. 0 can be written as 0, 0, 0. Okay. So first case 1, for lambda equal to 1. So put lambda equal to 1 here. So before that, by using cross multiplication rule, first I can take first 2 rows here. So x, y, z, again I can take x here. So first 3 minus 1 is 2, then 1 I can write as it is, again 1 I can write as it is. Then next one is 1. Here is put lambda equal to minus 1 means that is minus 1, then we get 2. Or we can choose second and third also. So whatever thing you have to use in the your convenient. Okay, so here is again you can write x as it is. So this x can be written as again x here, so 2 and 1. So by cross multiplication rule, so x by, that is x, y, z, so x divided by, that is first we can omit the x value. So 1 into 2 is 2, minus 1 into 1 is minus, that is plus 1, so we get 3. So 2 plus 1 is 3. Next I can take y value, so you can omit these things, then multiply these two. So 1 into 1 is 1, this one is minus 4, so we get minus 3. Next I can take z value, so z means, so 2 into minus 1 is minus 2, so 1 into 1 is minus 1, so we get minus 3. Everything must be in determinant form. Okay, so this one is positive, next one is we can take the negative values. So therefore x, y, z is 3 minus 3, 3. Therefore x1 equal to, here is we can divide by 3, 1 minus 1 minus 1. This is the first eigenvectors. So next second eigenvector is put lambda equal to minus 2 from the given equations. Here is lambda equal to minus 2 means, so we get 5. So here is I can write 5, 1, 1, then 1, 2, 2. Again we can write the same element x here, 5 and 1. So by using cross multiplication rule, same thing here. So first I can choose x value. So x means, so 1 into 2, 2 is 2, here is minus 2, so that one is 0. Next one is I can take y value equal to, so y means I can omit these elements, the remaining is 1 into 1 is 1, so 5 2s are minus 10, so we get minus 9. Next I can take z value, so 5 into 2 is 10, 10 minus 1 is 9, so don't take this one. So therefore x2 equal to 0 minus 1, 1, so divided by 9 here. This is second eigenvector. Then put lambda equal to 4 from given original matrix, so we get minus 1, 1, 1, 1 minus 4, 2. Again we can write the same x value, this one is minus 1, again 1, so same procedures. So first I can take x value means we can omit x, so multiply these two. Next y means multiply these two, then z means minus 1 into minus 4 is 4, 4 minus 1 is 3, so we get 6, 3, 3. Therefore x3 equal to 2, 1, 1. So this is a third eigenvector, so we can divide the common term here. Here is also we can divide the common term. Therefore x1, x2 are the principal axis, and lambda 1, lambda 2 are the principal normal stress. What is lambda 1, lambda 2, lambda 2, lambda 3? That is a principal stress is based on the eigenvalue. The eigenvector is nothing but the principal axis, x1, x2, x3, that is a direction. So therefore there is no shear stresses available in this problem. So this is the idea to finding the solutions, principal axis and principal stress. So principal axis is based on the eigenvector, principal stress is based on the eigenvalues. Okay, thank you.